Distance, velocity and acceleration. Well, firstly we'll look at a few definitions. The position is denoted by x. Its derivative, dx dt, is the velocity, and the second derivative, d squared x dt squared, gives us the acceleration. Now, a few key phrases that are used in these questions you need to interpret when you see these words. If you see the word initially simply means when t equals 0, when time is 0. At rest, if a particle is at rest or if it's stationary, then that means it's not moving. So its velocity is 0. Very good. Question 1. A particle moves along a straight line so that its distance x meters from a fixed point O is given by x equals 6 minus 2t plus 8 log of t plus 3, where t is measured in seconds. 3 parts. A. What is the position of the particle initially? Part B. Find expressions for the velocity and acceleration of the particle at time t. And question C. Find the time t when the particle is stationary. Well, let's look at a solution now. Well, firstly we'll write down our equation that indicates position. Alright, x indicates position, and we're asked to find the position of the particle initially. Again, that word initially, what does initially mean? It means at the start. It means when time equals 0. So when time equals 0, if we substitute into the equation above there, where x equals 6 minus 2 times 0 plus 8 log of 0 plus 3. Well, that equation then simplifies to eventually be that x equals 6 plus 8 log 3. Right, so that's its initial position. Moving on to part B now, we need to find expressions for firstly the velocity. Now the velocity is the first derivative, so dx dt. So we're going to find the derivative of the x equation above. So firstly, the derivative of 6 is 0. The derivative of minus 2t will be minus 2. Then we have the derivative of a log term. So we write our 8 firstly, and the log t plus 3. Well, the t plus 3 will just go down the bottom, and you'll find that's it. That'll be the derivative of that expression. Now it's the velocity, so I'll just write that in brackets just to recall that it is velocity. Acceleration now. The formula for acceleration would be the second derivative. So we need to, in other words, it's the derivative of the velocity equation above, where all we've done there is just rewritten that 8 over t plus 3, rewritten that as 8 times t plus 3 to the negative 1. So we need to find the derivative of that. So let's go through. Derivative of minus 2 is nothing. Then the derivative of 8 times t plus 3 to the minus 1, well, the minus 1 would go down the front and multiply by the 8. Eventually we'd get minus 8 times t plus 3 to the negative 2. Now that's our acceleration. So therefore we write the acceleration minus 8 over t plus 3 all squared. Very good. Now part C. Find the time t when the particle is stationary. Well, stationary. Stationary means it's not moving. It means its velocity is 0. So we write when v equals 0. So there's our velocity equation. We just need to substitute the velocity is 0 there. So when we do that, we get that minus 2 plus 8 over t plus 3 is equal to 0. Now solving that minus 2 can certainly go over to the other side, become positive 2. So you're getting 8 over t plus 3 equals 2. And we can solve this, if you like, by inspection. So in other words, the t plus 3 down the bottom, if we think about 8 divided by something is 2, well, that something would have to be 4. Alright, the t plus 3 would have to equal 4, since 8 divided by 4 equals 2. Alright, when that's the case, then solving that, t plus 3 equals 4, simply t must equal 1, and we're dealing with seconds. Terrific. Very good. Look at another example now. Question 2. A particle moves in a straight line so that its velocity v in meters per second at time t is given by v equals 6 minus 2t. Initially, the particle is at x equals 1. Part A, find the displacement of the particle as a function of t. And part B, find the distance that the particle travels in the first 5 seconds. Well, as we've seen before, if we start off with position and we're asked to work our way down there, like for example find the velocity and acceleration, it involves differentiation. On the other hand though, let's say we start down the bottom here at acceleration and need to work our way up to velocity and then position. Well, the opposite of differentiation is of course integration. So if we start somewhere on the table, then we need to work our way up. That will involve integration. Righto, the solution to A, we're asked to find the displacement where we know the velocity. We're given the velocity, so we can write our velocity equation down, and remember the velocity is in fact dx dt. It's the first derivative. So looking at our table there, we're starting with the velocity. We're asked to go up to find the position. That's why we're going to integrate as our first step. So integrating, let's see. We have x equals integral of 6t, minus 2, the integral of that, we minus t squared, and this is very important. We need to add the constant of integration. Very, very important. And then we need to find it. So we're going to use our initial conditions. It says initially the particle is at x equals 1. Now recall what does initially mean? Initially means when time equals 0, we're told that x is equal to 1. So we're going to substitute those two values in to our equation above it. When we do that, we get 1 is equal to 6 times 0 minus 0 squared plus c, and as you can see, works out to be therefore that c is equal to 1. Very good. We can then now write our displacement. So in that highlighted equation above there, we're just replacing the c with the number 1. So we finally get x equals 6t minus t squared plus 1. Tremendous. Part B. Find the distance that the particle travels in the first 5 seconds. Well, the distance travelled, you'll find, is the area between the line and the x-axis in a velocity time graph. The reason it is that is because, remember our formula, distance equals velocity times time. So we find the area in a velocity time graph. Okay, well firstly we need to, there's our velocity equation, we need to draw up its graph, and there it is. Notice the axes v and t. T is always the horizontal axis, time. So there's our line graph. V equals 6 minus 2t. We chose 0 and 5 because it's in the first 5 seconds, and we need to find that area. So that area will actually give us the distance travelled in the first 5 seconds. So we'll call that area 1, and we'll call that area 2. So area 1 is a triangle, so it's half base times height. So it's half times 3 times 6 works out to be 9. Area 2 is fairly simple as well. Works out to be a half times 2 times 4, which is 4. So therefore the distance is the sum. It's 9 plus 4, works out to be 13 meters. So there we have it. So just to recap there, the last step, if we're asked ever to find the distance travelled, we need to find our velocity equation, and then we draw its graph and work out the area under the curve between, if it says 5 seconds, okay, we'd be going from 0 to 5. Tremendous.